Hi everyone. Minutes. Hi Jamie. How are you today?
Hello, Katerina. I'm okay, thank you. How are you?
Good, good. Thank you.
Hey, tell me, when a notification pops up and it says, like in this instance, Katerina has started the room. Do you want to join her? Right? That notification seems to vanish very quickly, and I can't find. Does it go to bulletin or does it go to activity? Can you find it somewhere else, or is that it just gone?
So I think on the bell next to your profile picture, all the top on the left hand, there's like a bell sign, and there is all the activity that is happening around you from people you follow. There you
Right.
should be able to see it. I'm not sure how it works for you, like
Yeah,
where
yeah,
that
I
bell
understand.
is.
hmm
But
hmm
there is an activity button where you can check what notifications you recently got.
Cool, because yeah, sometimes I'm seeing these and they're like invites to a certain room, but then they go away very very quickly, and I go, where are they? Anyway, not a problem.
Yeah, let's wait maybe another 2 minutes, everyone, and then we'll start with our weekly recap, talking about the guest speaker, a short version of what the guest speakers were talking about this week. So, and we'll make a recording out of it at the same time, which is very convenient. So we know we don't have to hand edit it. So, and if you want to come up and ask questions, please come. You're welcome to do so. And yeah, it's been another interesting week. What do you think was your favorite, Jamie? You didn't have a favorite?
Oh, there was they were all good, and don't make me choose. Um, uh, One talking about life in space was incredible. What about yourself? What one captured you the most? The one about memory and
Really?
time was incredible too. Yeah, go. Yeah.
Oh, no, it's hard for me to choose. I don't know.
Will you give that to me? You put this responsibility on me.
I think
Um,
it could be that you had like a favorite. I don't know. Sometimes you have like a favorite, and then
the one about the perception of time and the experiment that was done was kind of mind blowing, and looking at how the brain just less blowing away it. Oh, okay, worded properly, Jamie. The talk was incredible, and the experiments were actually quite down to earth and easy to understand. But what was mind blowing was the perspective on how we actually do perceive causality and time. That was blowing my mind. And talking to the doctor about um, how we are taking in information and how we're sifting through it. And sometimes, are we inventing our perception of time, or are we building it from something we're perceiving? Was quite a mind blowing thought. That was definitely a really good one to me.
we can slowly start now. We As I said, welcome everyone to the Science Society. This is the weekly recap room where we just very shortly summarize what was going on this week and at Science Society. If you missed the room or you want to remind yourself again what happened here, this is the room basically. Maybe you had the question. We are not the guest speakers, but we will try to discuss this. So, yeah. So the first room here was about was with our guest speakers, Lisbona August Ambato, and she's a senior research associate at the Sci Genome Labs, and she does really interesting research in the field of stem cell research. Um, yeah, it also always goes a little bit into rejuvenation and stuff like that. And she recently published a paper as first author, where they used a short duration of high frequency megahertz order nanostimulation. And with that stimulation, they could drive any type of stem cell um, into osteogenic differentiation. And this paper was focusing on MSC cells. So, but she also mentioned during the talk that they could do that with any cells. So basically into bone cells, differentiating. And it was really interesting to hear that with that vibration excitation, they basically forced these cells to become bone cells in the lab. So what they did, they extracted stem cells from patients in the petri dish. Basically, they gave this short duration of this vibration stimulation, and in the dish they started differentiating into bone cells. And then what they are doing, they are putting these then back into the patient. And usually people do this type of differentiation work. They give them basically signal compounds. Um, so basically people do a chemical differentiation stimulus, and this takes way longer. And they could these cells were fully differentiated in 5 days, and usually this takes 2 weeks. So this technique basically cuts down significantly the cost, because it's quite expensive to keep these cells in the lab. It needs to be completely sterile. You need professionals to take care of them, that are quite expensive, and so on and so forth. So if you can cut down more than half of the time for this process, that is really helpful to reduce cost. And yeah, so what basically was happening in the cells, but they need to go more deeper into the exact mechanisms that happen, is that calcium, there's a calcium signal triggered by this frequency that then stimulates significant, like upregulation of significant markers. And it was RUNX2 and COL1A1 that basically turned these cells then into these bone cells. So it was really elegant and really interesting work. And we asked if maybe there is a different way, like using different types of simulation and turning the cells into other cell types for other implants. They didn't try it yet, but now they are going into clinical studies, or they are doing clinical studies with this. And yeah, it's a really promising technique.
That was an absolutely fascinating talk when she was saying that they could actually direct the stem cells and how they actually want to change it, that they didn't get the frequencies right. They said it's going to be a lot of testing and a lot of exploration and a lot to find out. But if you could take stem cells and just use, it's like what, sound waves, to transform them into something that we could really need in our own bodies, oh, that would be so, so incredible. There's a lot of potential there, and it was nice and cheap, right? You already said that it was going to be so much cheaper than anything else that could be offered because it had these teeny tiny little machines, and she had to even go into engineering, didn't she? She had to bridge her own skill set into engineering just to understand the tools that she would need just to do this. It was amazing.
Yeah, I agree. It's really cool work. It's and really important. So for bone fractures, for people that cannot heal well anymore. Um, yeah, I think it will have um, a lot of applications in the future. People with osteoporosis and so on. So I think yeah, it's amazing work. Then we had Associate Professor Timothy Brady here on Tuesday, and he's in Queensland Brain Institute, Doctor of Neurological Sciences, and he talked about non-coding RNA and how it drives fear extinction through direct interaction with the chaperone protein. So this was really interesting, and the title was kind of provocative. That's how I made the title. Was how junk DNA could help us address anxiety disease, basically disorders, and we are learning more and more about non-coding DNA that we previously thought was junk DNA, like because it wouldn't directly turn anything into a protein, and people just labeled it when they found out about it that it's junk DNA, and it's a very high percentage of our DNAs. And now we are learning more and more about this non-coding DNA, what they are doing and what role they have, and that's a lot of regulatory role, gene expression mechanism modulations, and yeah, and Tim Brady, he that's his main focus of his research, and he found that this non-coding RNA, so it's RNA that doesn't get translated into protein, um, it's highly involved in fear extinction. What fear extinction means is that you basically have a fear memory, a traumatic memory, and through exposure therapy and in mice, basically to basically play the trigger over and over without that any really harm happens over time. You basically learn that there's no reason to be afraid anymore from the signal, and then you just go around with your regular behavior without freezing or having this regular behavior display of a traumatic experience over time. And this is extinction learning. And yeah, he found that there are specific non-coding RNA that plays a very important role in this fear extinction learning. And the cool thing is, once we know that, and we have people that have very unflexible PTSD, that they don't learn anymore, um, that something is safe now, that they are in a safe environment now. One could use this knowledge one day to basically upregulate or enable them to have this extinction training, so that they learn that the environment is safe now and go on with their lives. So yeah, this was a really interesting discussion, amazing talk. He was a really great public speaker, answering all these questions we had and everyone else had. And yeah, I think it was amazing.
This one was incredibly exciting as well because this is one of the ones that not only were you hit with a lot of incredible facts about the brain and how it works, and I always love that, but on top of that, when you started to look at the far-reaching implications of a study like this, it showed that there actually is things in the brain that can help you go over trauma. Sometimes we might just need a little bit of help. Not to be confused with anything crazy like brain control or anything like that. These are just going to be tools that are going to help people. Maybe with that alongside, you mentioned this cognitive therapy afterwards or something like that, because it's like this could help the mind when it's finding a difficulty moving past something, and then after that, behavioral changes or behavioral life changes afterwards. But this could help not only the amazing help it could be to PTSD people, like in for war or tragedies or anything like that, but it could even, in theory, go so far as in the future to help people get over things like phobias. And even to the point of things like I suggested at the time, public speaking, even fears like that, like the kind of things that just trigger off our fear responses, and that we find debilitating. This could be a genuine treatment in the future to actually help you get past it. There's a lot of people out there that could definitely probably empathize with something like that. So if you have time, give that a listen. Very, very worthwhile.
Yeah, I agree. It's really amazing. And then next we had Dr. Christos Bechlivanidis. He's an associate professor, experimental psychology, and he is at University College London in the UK. And his main research area is the role of causation in perception learning and reasoning. And he is very interested in the relationship between perceptual judgments of causation and judgments of time. So, what happens when assumed causes take place after their effects? Can the causal interpretation of the environment distort the order in which events are represented in the mind? And he's also interested in the way people generate and evaluate explanations, and in particular, the role of abstraction in everyday explanations. And yeah, this was, as Jamie already referred to, um, at the paper he published. The title is "Human Vision Reconstructs Time to Satisfy Causal Constraints." So yeah, and he showed exactly this. So what they did was to show pictures in a specific order to the different subjects, and what happened was that people the pictures didn't like necessarily show a story, like it was not a mixed up picture story experiment. It was just different pictures shown in a specific order, and then people reconstructed the order of the picture to kind of make a causality construct out of it. So that was really, really interesting. That the subjective order of the visual input they got of these different pictures um, was always different, and in a way that it kind of satisfied individual subjective causality of the individuals. So that was very intriguing. It was a really interesting discussion, and we had really interesting questions. I thought actually the question from a non-scientist that was really interesting about what's with meditation when people train themselves to meditate, to focus. And we asked them the question if, for example, training of meditation, if people that go through this for a long time and are very well trained to be mindful in the present moment and so on, to see things as they are and so on, if that would be different in individuals, and maybe then the contrary would be if people take drugs that completely change the perspective of the individual, if that would be like also very different, if that would generate a very different results. They haven't done that yet, but they thought it was a really interesting questioning. We also asked if this would be maybe also different in people with split brain that went through splitting the brain surgeries because of epilepsy. So yeah, I think this work was really interesting. It opened up way more questions, which is usually the sign of a really good study. If you basically start a study
Mm-hmm.
and you generate a new field basically with way more studies to follow up, and I think this is one of those studies, and we are very curious to see what he will do next. But he answered in the email that these were all great suggestions and that he is considering them to do them, so that was really cool.
That's exciting to think the Science Society can do its little part to advance the ideas in science. That is amazing. And all of you people listening to this, they're all part of it too. So thank you for joining us.
Yeah, exactly, I agree that makes it way more fun. So um, we had actually a room in between that I forgot about because we had done two rooms, was the team that was here that talked about um, quantum charging battery.
Quantum charging.
Exactly.
Yeah.
That was the whole team was here, which was a lot of fun. Their lab is in South Korea, and it was Yoo Jim, Dominic Safanek, and Dario Rosa. They are all theoretical physicists, and they do really amazing work in quantum mechanics. Um, and they came up with a way that you could basically charge a huge battery, such as like an EV battery, like for electric cars, in like a couple of minutes. And what they did was to basically use the quantum mechanisms to charge the EV. Oh, I didn't put the paper up. Jamie, you can fill in what you thought about the room while I put the paper up. Thank you.
That one was absolutely mind blowing as well. I keep saying this every time. I'm going to make my expressions all redundant if I don't have to. I'm going to have to look up a thesaurus just to come up with new adjectives to describe these rooms and how amazing they are. The quantum one was incredible because not only was each of the team diverse in their backgrounds and how they got there, but they worked so well together. They were a real team, and they were here. They were answering lots of great questions. It got very quantumy. Everybody who loves quantum, jump in. There was a lot of that. Um, there was also talk of changing the new technology. So there's a lot of people who are saying that, oh, this will never work. It'll burn out all of the plugs and the plug sockets and blah, blah, blah. And they said what it is they're trying to make everybody understand that this is going to be a brand new technology. So we're going to be in a lot of senses, hopefully, throwing out all the old plug sockets that we've got and all the old systems and having something brand new in, something with a whole different sci fi type of technology, except for it'll be science fact, which is always exciting. And that will let you plug in your car and have it done in minutes. There were even discussions there when people threw the ideas out to put some kind of charger things under roads so that when cars were driving, that was only
Yeah.
just everybody shooting ideas out. But the idea that the car could charge as you were actually driving on the road, which would be completely cool.
Yeah, that's true. So the main ingredient here is that instead of galvanic batteries, what we are using now is that in a quantum battery, the stuff that it is made of are qubits. and you basically want in this quantum battery to create a preferred orientation of the qubits, and if you when you charge the battery, you bring them into a very specific state, and for that you would need to you can only do this with a laser. This was shown that you would need a high energy laser to basically all at the same time change the qubits um, from a low energy discharge state into a high energy charge state by aligning them. And why this is way faster is that you have basically, you can have all these quantum qubits sitting at the same table basically, and with the laser you could um, change their align their states all at the same time. The cool thing about this on top is the bigger the battery, the faster, like the faster you will charge it, because the best possible advantage is that n times the number of cells will be the acceleration basically of charging. So when you have a battery that consists of 10 cells, it will be 10 times faster than the regular charging mechanism. If you have a typical Tesla battery, which consists of 7,200, you will be 7,200 times faster. So this
Wow.
means that instead of with a regular, not a supercharger, but with a regular charger, instead of having it charging 10 hours, you will be under 3 minutes. Yeah,
It's so counterintuitive to how we've had to suffer in the past with hours and hours of charging times.
exactly. So that's
No,
a huge advantage. But they also said we don't have the infrastructure right now to do this. We don't have currently a charging infrastructure with these high power lasers. You also need to basically isolate the qubits from the environment well in an EV. So that's another hurdle that we have to achieve. But if we do, we can basically overcome this, and they gave kind of a timeline of around 8 years or so that we would be able to do this quantum charging.
all incredibly exciting stuff. And I did ask them at the time, if you go back, if this technology was going to be akin to what the mobile phone did to the common telephone box, and they said that Um, in the short to medium term, no. It's only going to be employed probably in special places for a time till, like Katerina said, infrastructure changes. We sort of get then we evaluate its uses fully, but eventually it probably will. And these kind of plugs could be considered to be caveman plugs in the future, other than in special circumstances.
Yeah, we'll have a new type of laser development room next week. So that will be interesting to go into that, following up these quantum charging technology. So I think we'll have that room on Tuesday, which I'm really excited about. No, on Wednesday, nanospacer, nano optics, and nanospectroscopy. Yeah, it will be interesting. So, yeah, I agree. It's an exciting time. I can't wait until we have this quantum charging battery.
I also would please like to throw it out there to all the avid listeners of the Science Society that every speaker you will find now, we're very quickly developing quite a catalogue of speakers. And if you have one speaker talking about stem cells, there'll be another speaker talking about the RNA and how stem cells are made or used or manipulated, and another one talking about the biology of how these are even created in the first place. You'll actually find an incredibly intricate connection of the biologists and physicists. There's a lot of crisscross here for the people that love sifting through these kind of things and finding common features. So one of the things I'm finding very exciting.
Yep, I agree. Um, the times of cutting up science and all these different blocks, I think, should be over by now. But yeah, on Friday we had Dr. Sergei Krasnokutuski and the building blocks of life form on space dust. He's at the Max Planck Institute for Astronomy. He's a researcher from the Ukraine, um, and he is interested in all these different types of um, of how these building blocks of life could be maybe forming on space dust. And this was really cool and elegant work, where they kind of created the the parameters or the factors that could be would be out in outer space on surfaces, on different surfaces. um, and they were able, in this very cold environment of 10 Kelvin, produce this very first peptides. There, if you click on the paper, you can see the the figures they made to look at the diagram and how the energy levels for these reactions from CO and CnNH3 um, work. And it's it was fascinating work, because what they have shown is that with stuff that is in outer space available quite abundantly, even under these very cold temperatures, on different types of surfaces, like the surface part is important, but what type of surface is really not important. And they showed this here too, that these first building blocks for life could be created, and it wouldn't be really anything special that peptides are created on space dust. And we kind of go further and further down the timeline when life on Earth was first detected. It's getting basically earlier and earlier the more we find. And if we have already the peptides formed beforehand, it's really not that special to basically have the first forms of life, since peptides can be the building blocks and also catalyst. And we've shown the same thing also for RNA before this study. So yeah, it first of all, Jamie asked also the question: does this support the theory that there is a lot of life out there in the universe? And he said yes, this does support this view, and he had this view way before anyways. But yeah, and and now we not just have the RNAs as an important first building block that could be formed quite easily, we also have peptides. So yeah, I think that was really cool.
incredibly exciting, and that it was actually seeing how changing our view in space. For a lot of us, space is this almost dead, inert place with a few things floating up in there, and discovering that actually out there in the vastness of space, there's a big sort of ballet of chemicals and possibly organisms that are all connecting together and making simple things in ways we don't understand. It's kind of incredible. Even if it wasn't me leading us to find life or anything that huge right this second, it's shown there's a lot more going on out there than we ever expected, and I always find that inspiring.
Yeah, I agree. It was a great room, and yeah, this was our really exciting week. Um, if you want to know more details about the different rooms we just discussed, please be feel invited to listen to the replays, or just if you're on the replays to go on the click on the different presentations. Most of the guest speakers um, made for us, specifically for us. I made them available through our Google Drive here. Everyone can view it, and yeah, I think this was another great week, and we have another wonderful week ahead. So it's really cool. So tomorrow we have Dr. Singh, and he will talk about his research with machine learning. He found a new way to find new rare earth compounds. Rare earth compounds are really important, especially for photovoltaic and renewable energy and all kinds of technological stuff we need nowadays. And then we'll have on Tuesday Dr. Person, and also his colleague will come, and how gravity emerges, and about his their holographic principle. This will be a really interesting room. Then on Wednesday, as I said, we will talk about nanospacer, so a different new type of laser, nano optics, and nanospectroscopy. And on Thursday, we will have Dr. Alahem talking about Parkinson's disease specific gene signatures. And on Friday, we will have Dr. Sarwat from EBM in Switzerland coming to talk about neuromorphic computing and neural networks. So, yeah, it's another really exciting week, and I can't wait, actually.
That's going to be pretty exciting. We're covering a lot of different topics over a lot of different areas in science. So anyone who can listen, listen, be there or be square. Or if you can't, make sure you listen to the replays on your way to work, in the car, anywhere, in the shower, even. Definitely give them a listen. Do yourself a favor and be a little bit smarter every single day.
Exactly. Uh, on the Monday after, we will have a really also big scientist coming to talk about how his lab discovered a new mechanism for long-term memory storage. So it's also a really big name scientist who will be coming. So yeah, we are booked out with guest speakers until mid-June by now. Yeah, we will have almost every, unless people reschedule until then because something comes up, we will have every weekday a major guest speaker coming until mid-June. It's booked out. So yeah, it's exciting. We'll see how I can manage that in the summer because I will be traveling and so on. But for now, until June, we are set with a lot of amazing guest speakers. So yeah, join the club, come back. Thank you, Jamie, for helping here with the moderation. This was a great room, I think. And yeah, Thank you, everyone. Enjoy your Sunday, and hear you all back next week on Monday. Thank you.
Thank you very much, Katerina, and everybody. Have a good weekend. Well, what's left of it. And we'll see you on Monday.
Yep. Bye, everyone.
Bye.